Hello again, Algebra 2. This is the second video for section 3.1. Last video was all about the substitution method. This one's going to be all about the elimination method. Again, I don't care which one you use. Your pick. They will work every time. Both of them will. So your pick. Sometimes, me personally, I use one over the other depending on the situation, depending on the numbers that I'm given. So that's up to you, totally up to you. So again, my paper here is too crowded for me to actually do work. So we're going to take a look at 2, 5, and 7 with the elimination method here. So let's start with number 2. For number 2, I have 2x plus y equals 5 and 3x minus 3y equals 3. Now, there's a couple, again, there's always two different ways to do these, like more than two different ways. For the elimination method, a couple things are important here. I need to make sure that my x's are lined up, my operation is lined up, my y's are lined up, and my equal signs are lined up, and my constants are lined up. They have to be like that so I can work with them. The next thing we need, essentially what we're doing is this. I have A equaling B. So just a real quick explanation. I'll only explain this for this one. It's a little abstract, so bear with me here. I'm saying that this expression, 2x plus y, let's say that that is A. And 5, I'm saying, is B. Well, if A equals B, fine, that's great. Over here, 3x minus 3y, that's something that looks very different, but let's call it C. And 3, very different than 5, let's call that D. So A equals B and C equals D. Lovely. Now, if I were to, let's say I take A equals B, and I added something to both sides. I can add anything I want to both sides. Let's say I added C, for example. That keeps me in balance. It's on the left and the right. So I have A plus C equals B plus C. But I know that C is actually equal to D, so I could substitute it in, kind of using the substitution method that I used in the last video. So let's substitute it for this one. If C equals D, I have A plus C equals B plus D. There we go. Everything's in balance still. A and B were already equal. C and D were equal, so I can add them to both sides. That's essentially what's happening when we work with this. Eventually, I am going to add these equations, and I'm going to take A with C and add them together, B with D and add them together. I'm allowed to do that because I'm just adding equal things to both sides. But if I added them right now, notice what happens. I end up with 2x plus y and 3x minus 3y. If I add all those with like terms together, I get 5x minus 2y equals, and if I add over here together, 5 plus 3, I get 8. This equation right here is not helpful. Now I have one equation with two unknowns. That doesn't help me at all. So you don't want to do that. What we're going to do instead is take my original. I had 2x plus y equals 5, 3x minus 3y equals 3. I need to eliminate one of the variables. If I can eliminate one of the variables, I can solve for the other one. Now, what I'm seeing is this. Notice how this y is alone. There's no coefficient on this y. What I'm going to do is multiply the top equation by 3. Again, this is an equation. I can do anything I want to this equation as long as I do it balanced on both sides. So what I'm going to do is take equation 1, this is my little notation, equation 1, and I'm going to multiply it by 3. And this is what I get as a result. I get 2 multiplied by 3 to everything. Whew, try one more time. Multiply 3 to everything. I'm going to get 6x plus 3y equals 15. This guy I'm just going to keep right on through. So I have 3x minus 3y equals 3. Notice now, if I were to add the equations at this point, I have a positive 3y and a negative 3y. They are going to cancel each other out. So let's do that. I'm going to add these together. I get 9x plus 0 y's equals 18. So really that 0y, I don't need to write it. I just have 9x equals 18. I divide by 9. I get x equals 2. Now I do have to substitute this back in, so I do have to use the substitution method a little bit here. I'll just go over here, off to the side. I'm going to use the first one. So I have 2x plus y equals 5, but x is now 2. If x is now 2, I get that 4 plus y equals 5. Subtract that 4 off to the other side. I get that y must be 1. Hooray! So that's my final answer. My xy ordered pair is 2, 1, using the elimination method. Let's do another. And let's just go below a little bit. On your papers, let's go for number 5. Let's go for number 5. So I have 4x minus y equals 6, and 2x minus y over 2 equals 4. And I want to use the elimination method for this one. So for this one, I see that I could maybe multiply this guy by 2. If I multiply the bottom equation by 2, I'm going to get rid of this fraction, and it's going to make it 1y. So that'll be nice to cancel. So let me take equation 2 and multiply it by 2. Again, that's my little notation that I use. When I do that, my top equation stays the same. I get 4x minus y equals 6. My new equation is 4x minus y equals 4. Now, notice I could have multiplied by something just a little bit better, and what that little bit better was this. If I had multiplied by -2 instead, that would have given me a -4, a positive y, a -4. Notice how my y's are going to cancel out again. So that was my goal, getting the y's to cancel, negative and a positive. So you could have done that in 2 steps or 1 step, whatever. So I see my y's are going to cancel, so I'm going to go ahead and add these equations together. My x's, y's, constants are all lined up, so I can go ahead and do that. So positive 4x minus 4x, oh, interesting. I get 0x. Negative y plus y, interesting. I get 0y. 6 plus a -4, I get 2. Well, everything over here just becomes 0, and it equals 2. Well, that's not a true statement. In fact, that is very much a false statement. So, remembering back to our notes from class, if I have a false statement, what is my answer? How many answers do I have, and where are they? And that answer, hopefully remember, when I have a false statement, that means that I have parallel lines, meaning they never touch, meaning I have no solutions. No solutions. Absolutely none. There we go. Let's go for my last one. My last one here. Let's go for number 7. And I picked this one just because there's a fraction involved. So we have 2x plus y equals 8. 3x plus 3 halves y equals 12. Also, just a heads up, all of these have been easy in that the x's, y's, and numbers have been lined up nicely. If ever there is a time where they're not lined up nicely, you should fix that before you continue. So what we're going to do is my elimination method. Let's go for the x's this time. Let's try to eliminate the x's. Notice I can't multiply one of them to make it equal the other. Not nicely anyway. So let's do this. I'm going to take my little notation here, equation 1, and multiply it by 3. And I'm going to take equation 2 and multiply it by 2. Now, this, again, isn't the only way to do this elimination, but I wanted you to see that there's different ways of doing it, and especially this one, you could multiply the top and the bottom equation by something helpful. If I multiply the top by 3, notice that's going to make my 2x into a 6x. The 3x multiplied by 2, I get that 6x again. Well, actually, I should multiply one of them by a negative to make sure I have a negative and a positive 6x. So I'll just pick the top one. I'm just going to make that a -3. So I get, multiplying the 3 in, negative 6x minus 3y equals negative 24. When I multiply in the 2, I am going to have, on the bottom, a positive 6x, that's what I wanted, a 3y, how nice, and a 24. Yep, cool. When I add those together, and I can add them now because I got my x's to be what I wanted, they're going to cancel nicely, I get 0x. Oh, 0y again equaling 0. So this time, 0 equals 0, that's a true statement. And again, remember from class, what does that mean? What are my answers? Hopefully you're remembering. This means that I have 2 lines directly on top of each other. So really, it's one line. Just one line. Meaning I have an infinite number of solutions. An infinite number of solutions. And those solutions, are on the line 2x plus y equals 8. Or you could have also said 3x plus 3 over 2y equals 12. Either way, because essentially what this is saying, the fact that we got them to completely cancel like this, you would have the same line. So you could say this one, or you could say 3x plus 3 over 2y equals 12. Either or. So you have an infinite number of solutions, and they are lying on the line 2x plus y equals 8. There we go. So there are some examples with the elimination method. Again, your choice, substitution or elimination. Mix it up. Pick a different one every time. Your call. There we go. So we will continue talking about systems of equations in class.